Today I have an SAT math tip and trick that I want to share with you that deals with similar triangles. So to illustrate the similar triangles and how we can use them to save time and find the correct answer efficiently on the SAT math section, I'm going to use question 18 from SAT practice test 6. So it says in the figure above, angle or line BD is parallel to line AE. What is the length of C to E? So we're going to look for this length right here, from C to E. So the thing I see immediately is that we have similar triangles. How do I know that I have similar triangles? Well, I see I have a shared angle right there at CEA, right? This angle E right there, I'll put it in blue. And then I also see I have a shared angle at DC to B, right? At this angle C. So I see I have those shared angles, also have this shared right angle here, so I know I got similar triangles from that, right? So now at this point what I can do is, since I know I have similar triangles, I see that my hypotenuse CD, right? I've got this hypotenuse here, I'll put it in green so you can see it better. Okay, this hypotenuse right here. If I solve for that, I can actually solve for CE, right? And I have to solve for this hypotenuse CD before I can solve for CE, because I see my corresponding sides. In this case, I'll put it in, I'll just go ahead and highlight it. Okay, this side here from D to B, that corresponds to the side E to A and this larger triangle. And I see that the ratios there is obviously multiplied by 3, because 6 times 3 gives me 18. So I know that if I find my hypotenuse CD, then I can multiply that by 3 to get my answer for CE. So I see immediately what jumps out to me is I have a 6 here and an 8 here. I know 8 squared is going to give me 64, and I know 6 squared is going to give me 36. I know that's going to equal 100, and I know the square root of 100 is going to give me 10. So I know my hypotenuse will indeed be 10 then, right? For CD, that's not my answer though, because I'm asked for C to E. So I take that 10 then, multiply it by 3, since that is my ratio of my larger triangle to my smaller triangle, and I get 10 times 3 is 30. So my answer there would be 30 for the length of CE. So the big things to understand here is with similar triangles, you want to find that ratio of your larger triangle to your smaller triangle, or your smaller triangle to your larger triangle. Find that ratio. In this case, multiplying your smaller triangle by 3 gives you your larger triangle for your corresponding sides. Next thing you want to do is determine what you're trying to find, right? CE in this case, that's the larger triangle's hypotenuse. Now in order to do that, you need to know your smaller triangle's hypotenuse. At that point, I applied a squared plus b squared equals c squared in order to solve for that hypotenuse. When I did that, I found my hypotenuse of 10, multiplied by 3, got 30 for the length of CE. So that's how you want to approach these similar triangles problems, is you want to identify what you want to solve, you want to find if it's in your smaller triangle or your larger one, then use the corresponding sides to find what ratio there are between the sides, and then obviously you go ahead and solve from there. So hopefully this video was helpful. If it was, make sure to like, share, and subscribe, and as always, have a great day.